Hello everyone, in today's video I'll be discussing my theory on multi-dimensions. So, to begin, we have to start with nothing. Because in order for there to be something, there needs to be nothing. Okay, so starting with the first dimension. So, on our perspective, a first one-dimensional object would look like a dot. Okay, so I'm going to draw a dot here. That's what it's going to look like. And this object only has length. Travel for this object can be in two directions, either forward or backwards relative to the object. So one-dimensional objects I consider to be points in space. So they create an entire fabric in which other dimensions are allowed to exist. Okay? And it's very important to understand that time exists in every dimension and is created when movement occurs. So as this point is moved, so does time, or time is created because the point is moved. Okay, so that's the first dimension. Okay, so in the second dimension, we would look at an object and it will look sort of something like this, or like this, or like this. Okay, anyhow, this dimension has length and width. So draw length and width. And it can travel in four directions: forward, backwards, up, and down relative to the object. Now, what's very interesting is, my observation, I believe these objects to be electromagnetic waves. So, for example, light and sound. What's very interesting is that these electromagnetic waves in a vacuum all travel at the same speed. So as us three-dimensional beings looking at a two-dimensional object, we're going to be able, we experience time differently than a two-dimensional object does. So we, looking at it, we're going to see it from beginning to end, because it's going to travel really, really fast. Okay? So if I had a little light bulb here and I turned it on, I turn it on, it's going to travel so fast that I'm going to see it at this point and at this point at the same time. And when I turn off that light bulb, it's going to disappear. It's going to, disappear at the same time as I turn off the light bulb. Okay, that's very important for us to understand, because as we go on from dimension to dimension, we're going to see this is occurring for each dimension. So this also occurs for a second dimensional object looking at a one-dimensional object. Okay, moving on forward. Okay, so third dimension. We all know it because we live in it. We experience it every day. But I'm going to explain to you now. what do three-dimensional objects look like? Well, I'm still gonna go through it. Okay, I know we see it every day, but they'll look like this. They'll look like this. Or like this, or like that. Anyhow, we're gonna look at it. It's gonna look like two-dimensional, right? Because we only could see one face of it, so that's the only face we can see. Anyhow, a three-dimensional object has length, width, and depth. And it can travel in 6 directions: forward, backwards, up, down, and side to side, relative to the object. Okay, so I don't really need to go much in detail in here, but I guess we pretty much understand what the third dimension is. Okay, and now on to the fourth dimension. Alright, so the fourth dimension. This is where it's going to get excited, a little tricky, but I think you're going to grasp it, the understanding of this concept here. So I'm going to draw what a four-dimensional object would look like in the three-dimensional, in our third dimension. Okay, let's say that it was some sort of fourth dimensional square, and it was walking along our third dimension. We would notice it, and it'll look really weird because we won't be able to tell like if this is the face of it or if this is the face, because as it's moving, let's say in this direction towards the camera, this is going to be up front at one point, and then it's going to move backwards, and this is going to be up front, and then that's going to move backwards, and that's going to be up front. So it's going to be really, really weird and sort of morphing as it's coming towards the camera. Okay? Now, we know that a third dimensional object has length, width, and depth. Okay? And a lot of people will draw separate axes here, but I'm not going to take that approach. I'm going to draw something here to represent, well, I don't know what to call it. But what it does is that it's going to rotate its length, width, and depth. And as it does that, it's going to be morphing itself. Well, to us, it's going to be morphing itself in the in the third dimension. Okay, so travel for this object, for this fourth dimensional object, it's going to be forward and backwards, up, down, side to side, and some form of rotation that will allow it to morph. Right? So now it has 8 directions of travel. Now, okay, a fourth dimensional object, looking at us three-dimensional beings, we're going to look like we're traveling really fast. Okay, so if you remember before where I drew the light bulb and we turned it on, and we could see it here, and we can see it here hitting the wall. So essentially, that fourth dimensional object, or in this case, fourth dimensional being, if there is such a thing, will be looking at us, and is going to be seeing us from beginning to end. Okay. Okay, so one thing that I would like to add about the fourth dimension is that because of its ability to travel in these 8 directions, it's going to seem like for us that it's time traveling. Okay? So if we were able to access the third dimension or briefly travel within the fourth dimension, it's going to seem like it's time travel. Okay? And so that goes back to the light bulb, turning on the light bulb, seeing it from one end and to the other end immediately. Okay, we step up to the next dimension and you'll be able to travel back and forth through it. Okay. All right, so the fifth dimension. Well, I don't know how to draw a fifth dimensional object as a 3D in the 3D perspective. But I will, however, explain a fifth dimensional object's movement. And we could do that by working our way up from the fourth to the fifth. Okay, so we know that we have, this again, right, where this is length, this width, depth, and we have this here representing a rotation, I guess, if you want to call that rotation. So this encompasses the fourth dimension, an object's travel in the fourth dimension. So in the fifth dimension, what it'll end up being is essentially, I'll need to redraw that, but a little bit smaller over here. And I'll draw two arrows like this. So a fifth dimensional object can travel from this fourth dimensional plane, or this fourth dimension, to this fourth dimension. And essentially what that would end up being is traveling from one parallel universe to another parallel universe. So that's the fifth dimension. And four-dimensional objects will seem like they're traveling really fast to a fifth dimensional object. Okay? Now, how can we sum this all up together? I'll be showing that right after this.